If everything goes according to plan, we're going to enter a new era of astronomy. NASA's James Webb telescope's been reported to have detected a very strange light in the universe, which almost kind of changed how scientists looked at astronomy and space. So, join us as we show insights into the mysterious cosmic light detected by James Webb. Yay! The largest, most expensive, and most complex space telescope ever built, the James Webb Telescope, is now in space, and it has its final destination locked. The launch of this $10 billion telescope on Christmas of 2021, anticipated for over a decade, mind you, was both exciting and terrifying for thousands of scientists, and also engineers, managers, and support staff who carried out this mission to the stage. On February 3rd, NASA has announced that the first particles of light have made their way through the telescope, which is by far the closest the scientists have made it in their way to their ultimate goal: to use Webb to image the universe like never before. This achievement was confirmed by the infrared camera, one of the science instruments on board, which captured the photons. Now, you might be asking yourself, what exactly is a photon? Or maybe you have the definition in your mind, but it's vague. As quanta of light, photons are the smallest possible packets of electromagnetic energy. Photons are present everywhere in particle physics. They've fueled centuries of energy and remain an important tool even today. This data is vital for the next step towards Webb's science mission and towards getting actual images that might marvel those of us on Earth. The near-cam readings enable scientists on the ground to start aligning the telescope's 18 mirrors to form a fresh and clearer lens in the cosmos. We had model and computer simulations of what we would see, and when we pointed at specific places in the sky, and then the actual data looks very similar to the simulations. The James Webb telescope will stare deep into the gassy depths of the strangest of the world's atmospheres, searching for signs of life, and might even reveal several unknown secrets about distant galaxies that we've never even been able to imagine being able to see before. To perform all these functions, the Webb is fitted out with 4 primary instruments: a mid-infrared instrument, a near-infrared camera, and the near-infrared spectrograph. And finally, of course, the fine guidance sensor near-infrared imagers and slitless spectrograph. The mid-infrared instrument, or the MIRI, acts as both a camera and a spectrograph. It can sense infrared light that our eyes just fail to capture. Infrared light can help discover phenomena such as the redshift, which can help us understand how galaxies, stars, and planets form and evolve over time. MIRI is going to be a pretty crucial element in several of Webb's science missions. The near-infrared camera is the telescope's primary camera device, and Webb is relying on this for direct imaging, a method of detecting exoplanets around stars and other distant objects. The near-infrared spectrograph is somewhat similar to a prism, as light comes into the spectrograph and the instrument separates the light and then enables astronomers to decode what the light has then passed through. The NIR cam can also give chemical information about many different objects in space. A fine guidance sensor includes a near-infrared imager and a slitless spectrograph, which is a vital tool and is a key to directing Webb towards precise starts and getting a clear image of the target. It also helps pinpoint the first stars. A NASA spokesperson briefs this as part of the process. The telescope's mirror is progressively going to focus on HD 84406, a star similar in brightness and size to our Sun, which makes up the Big Dipper constellation. The full alignment is going to take about 3 months starting from now. Engineers Scott Acton and Chandra Walker of Ball Aerospace and Lee Feinberg of NASA Goddard stated that Webb's primary mirror consists of 18 individual mirror segments that all need to work together as a single high-precision optical surface. In the announcement, NASA also offers a nice precision in this entire process that it requires. What does the first light mean for Webb? Confirming that photons can pass into the telescope and show upon its detectors is crucial for the next step of aligning the 18 beryllium and gold segments that, as a unit, comprises Webb's mirrors. To bring each segment into the right position and to function together perfectly, the team needs to tweak their individual positions by focusing on the star HD 84406. Any final Webb image is essentially going to be a stitched together composite, so when Webb looks at an HD 84406 initially, it's going to produce 18 slightly variant fuzzy pictures of the star. The engineers are then going to need to match each picture to the right segment, and once they know what segment is producing what image, then they can actually just move the images into a single point with a much greater accuracy. And after that, they're going to move on to segment alignment, which is a stage where each mirror is brought in and out of focus to produce 18 in-focus views. Adjustments of the segments then result in 18 very well-connected telescopes, as 3 engineers explained. However, the segments don't really work together as a single mirror. Once the engineer achieves this goal, they can move on to a stage called image stacking, where all of the segmented images then come together to produce a unified picture with all the lights falling in one place. But the segments are still acting like 18 telescopes. Getting beyond that issue requires 2 processes, namely coarse phasing and fine phasing. They might be a tad bit technical to explain, but together they serve to line up the segments and make a picture like they produce more accurately and more clearly. Finally, the engineers will have to produce field of view corrections and little fine adjustments and tweaking to get the segments just right. Of course, their work isn't gonna get completely over by that time. They're not gonna be done. They'll still be required to turn to commission the different instruments on the Webb telescope. The process is pretty pliable and modular, so it allows for repetition after an average of 3 months of aligning the telescope. And after that 3 months, we'll finally be ready to proceed to commission the instruments, so saith the engineers. Now, there's nothing quite comparable to the moment where you switch a brand new gadget on for the first time. That satisfying ding in the newly polished glowing screen can almost feel as contributive to actually doing work. If you relate to this feeling, then you can truly understand what the scientists running the James Webb Space Telescopes must be feeling right now to get their hands on shiny new technologies. All of the Webb components are powered on and ready to disclose the cosmos like never before. It was revealed by NASA on January 31st from the Webb Telescope's Twitter and blogs that the telescope's collection of science instruments is now all on a crucial path to starting its era of discovery, which indicates the completion of a week-long process that began right after Webb launched into space on December 25th. The first instruments to be turned on were the MIRI instruments, or the mid-infrared instruments, and some other parts. Now, NIRCam, or the near-infrared camera, the near-infrared spectrograph, and the fine guidance sensor near the infrared imager and slitless spectrograph are also confirmed to be switched on. All of this is likely possible because only the telescope is now safely stationed at Lagrange 2, or L2, 0.1 million miles away from Earth, where gravity keeps the observatory in constant orbit beyond the Moon. On Friday, Webb's team also switched on the observatory's high-gain antenna, therefore boosting its communication line with Earth and ensuring the smooth return of images and other observations when the time nears. Ultimately, we might still need to wait for the summer to see the result of all this labor and millions and billions of dollars being spent in the meantime. But we do have some ideas regarding Webb's first targets, and that are slowly being revealed to us. Many of these are, of course, informed by what the main instruments on Webb are actually capable of. The supreme goal of James Webb's telescope is to be able to use infrared imaging and other tools to stare deep into the voids and vacuums of space as well as time. The telescope is going to reveal new information about the universe and, maybe in so doing, revealing its origin. Even the first ever stars. At the same time, it'll also monitor the planets and objects in our own solar system with our crisp set of eyeballs, pointing to an age of new astronomical discovery much closer to home. Now that the James Webb Telescope has safely reached its home spot L2 and its instruments are powered on and running, it's now possible for the scientists of Earth to turn off their instruments' heaters. These little radiators were crucial in preserving Webb's scientific instruments through the cold, climactic conditions of deep space, but now the instruments are cooled down enough to their ideal operating temperatures. NASA's comments in a recent blog basically said that it's going to take months, and it's going to lead to massive milestones in James Webb's telescope setup focusing on its mirrors. Feel free to leave your thoughts in the comment section down below, and I'll catch you later.